All right, guys. So here's the quiz, functions and inverses. I'm not going to tell you whose quiz this is. It's one of y'all's. So if you look, one of y'all lucky. Well, I don't know if you want to consider this lucky. Well, maybe, because I'm going to do all these questions. So I'm going to do them all, guys, and they're all similar. Some question number ones are rational functions, and some are square roots. But all the other ones should be more or less similar. So the process is going to be the same. It's just the numbers are going to be different. So I think if you watch this video, I think it will really help you out, guys. And if it does help you out, give it a thumbs up. And I guess you could also give it a thumbs down if it doesn't help you. But I'd prefer a thumbs up if you feel like if it helped you. So let's get into it, guys. So this one's the domain, and all of these answers are in interval notation. So you got it right. So yeah, that's it. No, guys, I'm kidding. That was a joke, but it was not even close to funny. So yeah, let's do this question. You care about the domain. What does that mean? That means for what values of x does this function exist? So all you got to do, you have a rational function. So since you have a rational function and on the top you have a linear expression, x minus 5, you don't worry about the numerator, you just worry about the denominator. You know that you cannot divide by 0. So the denominator is the difference of squares. That's going to be x minus 4, x plus 4. So the two numbers that you cannot be, x cannot equal 4 because 4 minus 4 is 0 and you can't divide by 0. And x cannot equal negative 4. If this were free response, you could say all real numbers except 4 and negative 4, but they have them in interval notation. So the way you do this, guys, you're going to say from negative infinity, you go left to right always. Negative infinity until you reach negative 4 first. So negative 4. Union, hold on, guys. Okay. And then from there, you're going to go, by the way, it's parenthesis because you can never touch negative 4, so that's why you can't have a bracket. And then you're going to continue again in negative 4, and you're going to go all the way to 4. Union, and then you're going to go from 4 all the way to positive infinity. Notice that they're all parentheses. Infinity is a behavior, guys. You can never reach it. And there it is, guys. This is called interval notation. All right, this one, find the domain. Notice you have a square root in the top. Remember that with square roots, the smallest value you can have inside a square root is 0. You can't have negative numbers inside the square root, guys, because then that would be imaginary. So you take the expression x minus 2 and you say, well, the smallest that can be is 0. And then you just solve for x. So x is greater than or equal to 2. But don't forget about the denominator here. Remember, you still can't divide by 0. And what makes the denominator 0? If x equals 6. So you cannot equal that value. So these two alone would be the answer if it was just an inequality form. But they have it in interval form. So what you do, you always read a graph left to right. You start at 2. So 2, put a bracket because it has an equal sign down there. Comma, and you're going to go all the way to 6. But you cannot touch 6, so put a parenthesis on that. And then union. And then 6 all the way to infinity. And there it is. You cover all the numbers greater than or equal to 2, except 6. All right, let's go to the next one, guys. On this one, they want you to figure out what f of x minus 3 is. So you're just going to plug in f of x minus 3. I don't know why it does. The little font, if you notice, there's little squigglies there. X minus 3 squared plus 5x minus 3 minus 3. So now, let's see, let's expand it. X times x is x squared. X times negative 3 is negative 3x. We're going to have two of those, so minus 6x. Negative 3 times negative 3 is positive 9. And then distribute the 5. So plus 5x minus 15 minus 3. So let's see, x squared. And then negative 6x plus 5x, that's going to be a minus x. And then, let's see, 9 minus 15, that's going to be a negative. The difference is 6, so negative 6, and then minus 3 minus 9. And then look for that. All right, let's keep going. On this one, they want you to do this. You already know what f of x is. You need f of x plus h. So f of x plus h is equal to x plus h, close it squared, minus 6, parenthesis x plus h, minus 8. And now we're going to expand it. So let's see what that is. X times x is x squared. X times h is xh. You're going to have two of those. So 2xh. I'm sorry, guys. Let me just turn off my phone here. There we go. It won't ring anymore. Well, I mean, it will, but it's on silent mode. So then h times h is h squared. and then distribute that 6 there, so minus 6x minus 6h minus 8. There it is. You can't combine anything. Now I'm going to do this part. So f of x plus h minus f of x all over h is going to equal, and I'm going to put the 1 in red here first, x squared plus 2xh plus h squared minus 6x minus 6h minus 8 minus what f of x is, x squared minus 6x minus 8. Oh, what happened there? Minus 8. All this is over h. Alright, I'm going to put the equal sign. I'm going to rewrite it, guys, where I have more space here. X squared plus 2xh plus h squared minus 6x minus 6h minus 8. Distribute the negative. Minus x squared plus 6x plus 8. All this is over h. I can see my phone light up. I might have to answer that. We'll see. If they text another 2 more times, I'll answer it, I guess. X squares cancel out. Let's see, what else? The 6x's cancel out, or 0 out, I should say. And then the 8's 0 out. Now that I have, every single term has an h on it. 2xh plus h squared minus 6h all over h. Factor out an h, and you're going to have 2x plus h minus 6 all over h. And then those h's cancel out. And you have 2x plus h minus 6. So that's what we're going to look for. Right there. Well, you got it right. Yay. Alright, guys, let's keep going. So let's see this one. Alright, so it says the domain of f of x is negative 4 to 6. So this is an interval, guys. These are all x values. So that's how you read these, because they already tell you the domain there. So negative 4, in order to have the parenthesis, at negative 4, that is a solid. So that should be, the domain is from negative 4, comma, and then it stops at 6. That's another solid. So it should be negative 4 with a bracket to 6. So number 1 is wrong, because it says which one of the following is true. The range of f of x is negative 3 to 9. Okay, negative 3 for sure. That is for sure, because this is y value is negative 3, excuse me, to 9. Yep, that y value up there is 9. So that one's true. The y-intercept is 0, negative 3. Yep, that one's true as well. F of 6 equals 0. No. F of, oh, maybe, I don't know. Nope, f of 6 equals whatever that number is, 3. So that one is false. That's an x coordinate, that's a y coordinate. It's saying that I have a point at 6, 0, and you don't. F of x is increasing on the interval, so this is of x values. These are x values, guys, 0 to 4. Yep, from x equals 0, you're down here, to x equals 4, you're up there. It's going up the whole time, see? So that one's true. So 2, 3, and 5. Alright, guys, let's keep going. Find the x and y-intercepts of the following function, and I have a function like that. So this one's pretty straightforward, I think. You got it right. X-intercepts or y-intercept, where you cross the y-axis. Plug in an x value of 0, and you're going to get 15. So 0, 15 is your y-intercept. So that's the first thing I would look for. Y-intercept there, 0, 15. This one has a negative, so out. Maybe, and, well, I guess none of the above could be a maybe as well. So now I want to look for x-intercept, so I'm going to factor this out. So let's see, 2 numbers that give you a positive 15 that add up to a negative 8. What's that? X minus 5, x minus 5, minus 3. X minus 5, x minus 3. So now, for what values will this give you a y value of 0? Well, if x is 3, 3 minus 3 is 0, and 0 times anything is 0. And if x is 5. Why did I equal it to 0, in case you're wondering, guys? Because the only time you touch the x-axis is when the y value is 0. So 5, 0, and 3, 0. And we look for that, and here it is. Alright, I think we're halfway. No, we're not halfway. We're almost there, guys. Don't worry, we'll finish quick. Suppose that f of x is an even function. Okay, I have an even function, and I have that point, and I want another point. Alright, well, remember, an even function is symmetric about the y-axis. Symmetric on y-axis. So if you're symmetric on y-axis, the point 3, negative 6, you're like right there. And pretend you're folding this green axis there, if you were to fold it, where would it land? That dot, well, it would land somewhere here. What point is that? I didn't draw it perfectly there, but that's fine. -3, -6. If it said odd, guys, it would be flip. So remember, fold the green and then fold the other axis. All right, let's go to the next one. Determine whether the following function is even, odd, both, or neither. Well, it's an odd function. I'm not saying this is an odd function. I'm giving you the property. It's an odd function if I have f of -x equals -f of x. And it's an even function if I have f of -x equals f of x. So, in both cases, I'm going to type in a -x in there and see what I get. F of -x equals 6 parentheses -x to the 4th power plus 5 parentheses -x to the squared power, or the 2nd power. When I do that, you're going to get 6 times x times x times x times x. Negative times the negative times the negative times the negative is a positive. So you're going to have x to the 4th. And I guess I didn't have to put parentheses there. And the -x times the -x is just x squared. And there it is. So I have 6x to the 4th plus 5x squared, which happens to be that function, f of x. So in essence, what I got is this. F of -x gave me f of x. That is a property of even. There it is. All right, guys, let's keep moving. Describe how the graph of g is attained. Oh, okay. So here's your parent function, and I'm doing that. So without even reading A, B, C, D, E, F, I'm just looking at this graph here. So horizontal shift 3 right. So I'm going to write horizontal shift 3 right. And then the next step I do is I do that vertical stretch by a factor of 2. So vertical stretch by factor of 2. And then you do that vertical shift up 4. Vertical shift up 4. All right, let's see which one it has. Let's see which one it is. First of all of them say vertical stretch vertically by a factor of 2. So you can't cancel anything. But let's see which one says horizontal shift factor of 3. That's vertical. Okay, I guess let's start with the first one. Stretch vertically by a factor of 2, yeah. Vertical shift up 4 units downward, no. You're going up, out. Vertical shift by a factor of 2. Vertical shift of 3 units up, no. Stretch vertically by a factor of 2. Vertical shift of 4 units upward, maybe. Well, that is true. Horizontal shift of 3 units to the right. Oh, there it is. There it is, guys. Let's see what this one says. Vertical shift 3 units down, nope. Vertical shift 4 units up, yes. Horizontal shift 3 units to the left, nope. You go to the right. There it is, guys. Letter C. State the translation of the key point 0, 0. All right. When they say 0, 0, they're talking about y equals square root of x, guys. So I have this endpoint, and I want to know where it goes now. So if I have this function here, you can figure out where it goes without having to use a calculator. If you use a calculator, I guess that's fine, but you don't need it, guys. Factor out that negative, and you're going to have x minus 6, and then plus 3. So what happens? I move to the right 6 times, and up 3. To the right 6 times, up 3. And then that negative makes it open leftwards instead of upwards. So that point is 6, 3. You got it right. Go to the next one. Suppose the point 2, 3 lie in the graph of the function. What happens when that happens? And okay, so what? Okay, let's just transform it already, guys. So the first thing I'm going to do, the first thing you do your horizontal shift. So that f of x minus 4 means 4 to the right. So move 4 to the right. So if I move 4 to the right, 4 plus 2 is 6. So the first thing we're going to do, out, maybe, out. And I guess maybe. So now it's between those three, 33% chance of getting it right. So the second thing you do the vertical stretch next. And the vertical stretch alters your y value. So let's see. The vertical stretch is a factor of 2. So take the 3 and multiply it by 2. 3 times 2. And then the third thing you do your vertical shift. Vertical shift. Take your 6 here, 3 times 2. and add 3 to it. 6 plus 3 is 9. So there it is. Alright guys, let's keep going. Given the following graphs of f and g, find f of negative 4 plus g of 6. Well, f of negative 4, that just means what's the y value when x is negative 4 for f. The red graph is f, so I go to negative 4 and I find that y value. That y value looks like it is 4. So that's a 4. And then it says g of 6. I go to the 6 here, I go to the blue graph, and when x is 6, it looks like the y value is 5. So that's 5. It looks like that. Yeah, it is. So 4 plus 5 is 9, and we look for that answer. This is just like number 1, guys. You have something over something. They tell you what f and g is. So for f, I just type 3x squared minus 4x. For g, I type x squared minus 4x minus 12. They want the domain. You don't even care about the numerator. You just focus on the denominator. So I'm going to find my zeros. Why am I going to find my zeros? Because you can't divide by 0, guys. So let's see. If I factor that out, that's going to be x, and 6 and 2. X minus 6, x plus 2. Why 6 and 2? Because I need to make sure that it adds up to a negative 4. So what will make the denominator 0? Well, if x equals 6 or if x equals negative 2. So these are values that you cannot be for the domain. So all real numbers except those two. So you read a graph left to right, you're going to go negative infinity, and then the next number you hit is negative 2. And then union, you're going to go negative 2 all the way until you hit 6. And then you do union again, and then 6 to infinity. So let's look for that. You got it right. There it is. All right. So this here, remember what we said, guys, today in today's notes. That means f composite of g of 2. So all that means is this, f of g of 2. That's all it means. So when x is 2 for the red one, or for the g, sorry, for the g graph, when x is 2, so you're looking at the blue graph, so here's 2, and what is that y value? That y value looks like it's 5. So that means this is f of 5. So now I go to the red graph, and when x is 5, it looks like the y value is 0. So the answer is 0. Oh, I'm sorry. So f composite of g of 2 is 0. Let's keep going. Again, that means f composite of g. So I'm going to type in g wherever into my f here. So f of, what's my g? 5x minus 2. So here we go, guys. F of 5x minus 2 is nothing more than 5x minus 2 closed squared plus 3 times 5x minus 2. This almost feels like it's the exact one from the notes, maybe, right? 5x times 5x, that's 25x squared. 5x times negative 2, that's negative 10x. We're going to have two of those, so minus 20x. And then negative 2 times negative 2 is a positive 4. And then you just distribute. 3 times 5 is 15x, so plus 15x. And then 3 times negative 2 is negative 6. Combine like terms. No, it's not the same one. I thought it was, but it's not. Let's see, negative 20x plus 15x, so 25x squared minus 5x, and then 4 minus 6 is going to be minus 2. So yeah, there it is, 25x squared minus 5x minus 2. Yay, happy face. Alright, on this one, find what g of negative 5 is, and then plug it into f. So g of negative 5 is 2 times negative 5 minus 3 times negative 5 squared. So negative 10 minus 3 times 5 squared is 25. And finally, let's see, negative 10 minus, if I have 3/4, that's 75. So that's negative 85. And now I'm going to plug that into f. So f of negative 85 equals negative 85 plus 4. So that's just negative 81. Another one. Sorry guys, I'm getting pretty tired. I've been up since 4 a.m. And I mean, I guess this is the normal time for me. What time is it? Almost 11? Yeah, it's not that bad. Math life. Alright, 101. Nope, that's a parabola. Parabolas are not one-to-one functions because they do not pass a horizontal line test. So for a function to be one-to-one, it must pass horizontal line test and vertical line test. Again, we have another parabola there, so nope. Check this out. That one is a absolute value, another no. And the only one there is just the square root one, number 4. So let's look for that one. There it is. That's the only one, guys. In case you need a visual, the two parabolas look like this guy, and then the absolute value just looks like something like that. And then the square root one looks like, if you want to be specific, 0, -3 with a vertical stretch of 2. I don't think I did a bad job there, a vertical stretch, but you guys get the picture. All right, let's continue. This one wants the value of the inverse function f of 3. So that's an x value on the inverse, but that means it was a y value on f. So I'm going to write that. Y value on f of x. So that's what I'm going to be looking for, guys. I'm going to be looking for a y value of 3. So here it is. So that means that this inverse function spits out -5. Let's keep going. F and g are inverse functions. Okay, so what that means is that g is the inverse of f. So write that down somewhere. So that's 5, 7. This is 7, -1. And they want to know what g of 7 is going to be. Well, that 7 was a y value. On f. So here it is. Here's the y value on f. So that's going to spit out 5. All right, next one. Find the inverse of the given function if possible. What's the square root? So it has to be a parabola. So yeah, well, it looks like you got it right. So I guess let's just do it. First of all, guys. Oh, they didn't try to trick you guys. Sometimes they'll put the same solution, but with a different domain. The range of this function is the domain of your inverse function. The smallest value you can have inside the square root is 0. So that's where this function right here, the square root function, that starts on the x-axis. So that means the domain of the inverse function is all values larger than 0. So right off the bat, delete, it's between these two. Now, how do we find it? Like this, guys. This is pretty straightforward. Remember that for it to be an inverse, it has to reflect across the line y equals x. So that means we can toggle the x and the y. X equals the square root of 6 minus 4y. So what you do now is just square and square. So you can have x squared equals 6 minus 4y. Move the 6 to the other side. So you're going to have -4y. I like to write the 4y on the left-hand side, guys. I hope that doesn't bother anyone. X squared minus 6. Divide by -4. Divide by -4. So you have y equals x squared minus 6 divided by -4. And they don't do that? Well, they kind of do. So here it is. I'm going to split it up, guys. X squared over -4 minus 6 over -4. You can do that. You can rewrite it like that. So now, that just turns into, you can write it as a -1/4 x squared. And the negative divided by a negative is a positive. And then the 6 over 4 reduces to 3/2. So if we look for that, there it is right there. They were at the 3/2 first. Alright, use the property of inverse function to determine which of the given functions are inverses. You can tell this real quick, guys, just by looking at your slopes. So remember the property of inverse functions. If you have your original, the slope is going to be the change in y over the change in x. But for your inverse function, your slope is going to be the change in x over the change in y. So there's a word for that. The word is reciprocal. So the slope just changes you just change reciprocal slope, guys. That's all you do. So I see a slope of 3. I see a slope of -1/3, and I see a slope of +1/3. It doesn't say opposite reciprocal. It's just reciprocal, guys. So it cannot be G. It has to be H and F. So F and H. Excuse me. So there it is, guys. I hope that made sense. I guess if it didn't make sense, you could have always done this, guys. So here's method 2. I know you guys are going to like method 1 better though. X, switch the X and the Y. X equals 3y minus 1. And just solve for y now. So I'm going to move that 1 to the other side. X plus 1 equals 3y. Divide by 3, divide by 3, divide by 3. So I'm going to write f of negative 1 of x equals x over 3 plus 1/3. And sure enough, 1/3 plus 1/3 x. That's the same thing as x over 3. Alright guys, let's go to the next one. We're almost done here. I think we just have like a handful more. 3 more. So yeah, I know it's a pretty lengthy video. I know it could get pretty tiring because all we're doing is calculating calculation after calculation after calculation. Plug in a 2p wherever you have an x, guys. So we're going to write 2p close it squared over 2p plus 2 minus 2p. And that's it. So 2p times 2p, that's 4p squared. And then 2p plus 2 minus 2p. So we look for that. Let's see. Is it this one? Alright, let's keep going, guys. I think we've done enough examples of this one. Let's do it one more time. I need f of x plus h. So 1 over x plus h plus 3. Okay, here we go. So now I'm going to write f of x plus h. Sorry, guys. Let me write it a little more legible. F of x plus h minus f of x all over h is equal to 1 over x plus h plus 3 minus 1 over x plus 3 all over h. I need to find a common denominator in my numerator, if that makes sense. So I'm going to multiply this one right here by x plus h plus 3 over x plus h plus 3. I'll multiply this left term over here by x plus 3 over x plus 3. When you do that, you're going to get this. You're going to get x plus 3 over x plus 3, x plus h plus 3. And then on the other side, you're going to get minus x plus h plus 3 over x plus 3, x plus h plus 3. And all that is still over x. Oops, over h. Sorry, guys. It's getting late here. So now the common denominators and the numerators are perfect. I'm going to distribute this this negative here. So here we go. I'm going to write it in one line, guys. X plus 3 minus x minus h minus 3 all over x plus 3, x plus h plus 3. Put the h up there. So now I'm going to zero out where you can. X is 0 out, 3 is 0 out. And now that I've canceled everything, I can cancel one of these h's. And what do you have left? I have left a negative 1 over x plus 3, x plus h plus 3. So there it is, guys. Where are you? Oh yeah, you got it right. Good job. There's a negative there. Alright. This one here, there's two ways. I mean, there's several ways. I guess the easiest way is just to plug in x plus 2 in there. And then once you have your final expression, plug in a 0. So let's go ahead and try that. F of x plus 2 equals 7 parenthesis x plus 2 close it squared plus 6 parenthesis x plus 2 plus 2. This is not necessarily my favorite way. I would have probably done it by just plugging in a negative 2 and see what that value is, because I know that this transforms your f of x 2 to the right. But whatever, floats your boat. 7, let's see, x times x is x squared, plus 2x plus 2x, that's 4x, plus 4, and then plus 6x plus 12, plus 2, distribute that 7x squared plus 7 times 4, what's that, 7, 14, 28, 28x, plus 28, plus 6x, plus 14, and let's go ahead and combine those two. I mean, really, you can already just plug in a 0, and you can already see what the answer is, but that's fine. 7x squared plus 28 and 6, what's that, 34? 34x, and then 28 and 14, 28, 38, 9, 44, 1 for 2, 42. Alright, if you plug in a 0, because that's where your y-intercept happens, right, when x is 0. If you plug in a 0, you're just going to get that 42 there. 0, 42. You could have gotten the answer, guys, right off the bat, if you would have just realized that this just means that f of x is shifted to the left. F of x shifts left twice. I might have accidentally said right earlier. Sorry if I said that, guys. F of x plus 2 moves f of x to the left twice. So that means plug in a 2 in here, and you'll get your answer. Because at that x coordinate equals 2, when you move 2 times to the left, you'll be on the y-axis. So look, 7 times 2 squared plus 6 times 2 plus 2. 2 squared is 4. 4 times 7 is 28. 6 times 2 is 12. And then you add the 2 there. 28 plus 12, 28, 38, 40 plus 2, 42. See? So you could have gotten it. Don't be a robot. Make sure you know what you're doing. And we've reached the last one, guys. Congratulations. You made it to the video. So here we go. Don't forget, if you felt that this video helped you out, guys, give it a thumbs up. -1 is a point on your inverse function, and 7, -3 is a point, another point on your inverse function. And they want the slope, they want the linear line of f. So the first thing I'm going to do, I'm going to find points on f. So points on f. So that happens at -1, -1, and 7, -3. Alright, so now that we know that, guys, I'm going to say slope. Oh, man, I must be super tired. I gotta switch those, guys. -3, 7. There we go. So now my slope is 7 minus a -1 over -3 minus a -1. When I do that, 7 plus 1 is 8. -3 plus 1 is -2. So I get a slope of -4. There's only one that has a slope of -4. It's that one. Everything else does not have a slope of -4. So there it is. I'm going to stop. Well, no, we're not going to stop. We're going to go ahead and get that number. So here we go. Y minus 7. I'm using my point slope formula. -4. X minus a -3. So plus 3. And now when I do this, y minus 7 equals, let's see what that is, -4x minus 12 plus 7 plus 7. And it looks like we're going to get -4x, and the difference between 7 and 12, 7, 8, 9, 10, 11, 12 is 5. And you keep the negative because 12 is bigger than the 7. And there it is, guys. Yay, we did it. We did it. Alright, guys. Hook me up with a thumbs up if you felt that this video helped you out. And I hope you get a good grade. Alright, talk to you guys later.